So then in the seventh grade, he got a hint of what real science is when he entered the county science fair and lost. It was really a sad feeling to sit there and not get anything while everybody else had won something, a bride said. This entry was slides of rock tissues, which he showed under the microscope. He realized the winners had tried to do real experiments, not simple make of a next display. Already the competitive spirit that day drives Richard Ebright was appearing. I knew that for the next year's fair I would have to do a real experiment. He said, the subject I knew most about was the insect work I had been doing in the past several years. So he wrote to Dr. Urgwat for ideas and back came a stack of suggestions for experiments. Those kept Ebright busy all through high school and led to prize projects in county and international science fairs. I'm extremely sorry. For his eighth grade project, Ebright tried to find the cause of a viral disease that kills nearly all monarch caterpillars every few years. Ebright thought that the disease might be carried by a beetle. He tried raising caterpillars in the presence of beetles. I didn't get any real results, he said. But I went ahead and showed that I had tried the experiment, that this time I won. The next year, his science fair project was testing the theory that viceroy butterflies copy monarchs. The theory was that viceroys look like monarchs because monarchs don't taste good to birds. Viceroys, on the other hand, do taste good to birds. So the more they look like monarchs, the less likely they are to become a bird's dinner. The Ebright's project was to see whether, in fact, birds would eat monarchs. He found that a starling would not eat ordinary bird food. It would eat all the monarchs it could get. Ebright said later research by other people showed that viceroys probably do copy the monarchs. This project was placed first in the zoology division and third overall in the country science fair. In his second year in science high school, Richard Ebright began research that led to his discovery of an unknown insect hormone. Indirectly, it also led to his new theory on the life of cells. The question he tried to answer was simple. What is the purpose of the 12 tiny gold spots on a monarch's pupa? Everyone assumed the spots were just ornamental, Everett said. But Dr. Urquhart didn't believe it. To find the answer, Bright and another excellent science student first had to build a device that showed that the spots were producing a hormone necessary for the butterfly's full development. This project won Ebright first place in the country fair and entry into International Science and Engineering Fair. There he won the third place in zoology. He also got a chance to work during the summer in the entomology laboratory of the Walter Reed Army Institute of Research. As a high school junior, Richard Bright continued his advanced experiments on the monarch pupa. That year, his project won first place in the International Science Fair and gave him another chance to work in the Army laboratory during the summer. In his senior year, he went a step further. He grew further cells from a monarch's wing in a culture and showed that the curled cells would divide and develop into normal butterfly wing scales only if they were fed the hormone from the gold spots. That project won first place for zoology at an international fair. He spent the summer after graduation doing further work at the Army Laboratory and at the laboratory of the U.S. Department of Agriculture. The following summer, after his freshman year at Harvard University, Albright went back to the Laboratory of Development of Agriculture and did more work on the hormone from the gold spots. Using the laboratory's sophisticated instruments, he was able to identify the hormone's chemical structure. A year and a half later, during his junior year, Albright got the idea for his new theory about cell life. It came while he was looking at X-ray photos of a chemical structure of a hormone. When he saw those photos, Albright didn't shout, Eureka, or even, I've got it. But he believed that along his findings about insects' hormones, the photos gave him the answers to one of the biology's puzzles: how the cell can read the blueprint of its DNA. The DNA is a substance in the nucleus of a cell that controls heredity. It determines the form and function of the cell. Thus, DNA is the blueprint of life. Albright and his college roommate James R. Wong worked all that night drawing pictures and constructing plastic models of molecules to show how it could happen. Together, they later wrote the paper that explained the theory. Surprisingly, no other one who knew him, Richard Albright graduated from Harvard with highest honors, second in a class of 1,510 students. Albright went on to become a graduate student and researcher at Harvard Medical School. There, he began doing experiments to test his theory. If the theory proves incorrect, and if the theory proves correct, this will be a big step towards understanding the processes of life. It might always lead to new ideas for preventing some types of cancers and other diseases. All of this is possible because of Albright's scientific curiosity. His high school research into the purpose of the spots on a monarch's pupa eventually led him to his theory about cell life. Richard Albright has been interested in science since he first began collecting butterflies. But not so deeply, he hasn't time for other interests. Albright also became a champion debater, a public speaker, and a good canoeist, an all around outdoor person. He is also an expert photographer, particularly of nature and scientific exhibits. In high school, Richard Eppright was a straight A student. Because learning was easy, he turned a lot of his energy towards debating and Model United Nations Club. He also found someone to admire, Richard A. Willeher. His social studies teacher and advisor to both clubs. Mr. Willeher was the perfect person for me then. He opened my mind to new ideas, Eppright said. Richard would always give that extra foot, Mr. Wellhead said. What pleased me was that here was this person who put in 3 or 4 hours a night doing debate research besides doing all his research with butterflies and his other interests. Richard was competitive, but Wellhead continued. But not in a bad sense, he explained. Richard wasn't interested in winning for winning's sake or winning to get a prize. Rather, he was winning because he wanted to do the best job he could. For the right reasons, he wants to be the best. And that is one of the ingredients in making of a scientist. So what he says here, the most important thing, line which has to be highlighted, and that is one of the ingredients of making of a scientist. Okay, what is that? He was winning because he wanted to do the best he could and for right reasons, and he wants to do the best. So he start with a first rate mind. So what is all important? To become a scientist, I shall read out once again in the end. And that is one of the ingredients of making a scientist. And what are their ingredients for making a scientist is? First, start with a first rate mind. Second, add curiosity. Third, and mix in the will to win for the right reasons. So a bright heart has all these qualities. From the time the book The Travels of Monarch X opened the world of science to him, Richard Eppright has never lost his scientific curiosity. This is written by Robert W. Peterson, and that's all for today. Thank you, good night, and good luck. Please do take care of yourselves. Thank you all. Once again, may God bless you all.